In this video, we're going to derive our formulas for this tangent of the sum of alpha and beta. And take a look at how those formulas are going to be applied. So by the definition, tangent is sine divided by cosine. So it's sine of alpha plus beta divided by cosine of alpha plus beta. We already have formulas for the sine and cosine of the sum of angles. So all we have to do is just write them out. Okay, so this is what we got. In the next step, what I'm gonna do, I'm gonna basically divide the entire numerator and the entire denominator by cosine alpha times cosine beta. Or we could write it as we're multiplying the numerator by 1 over cosine alpha cosine beta, and we're gonna multiply the denominator by the same thing. So essentially, when we factor it in, each term is going to be divided by cosine alpha, cosine beta, each term in the numerator and each term in the denominator. So that's why I already have it here written like this. And so as you can tell, some of these factors are gonna cancel out. So here I'm gonna cancel out cosine beta and cosine beta. So what do I have left? I have sine alpha over cosine alpha. Well, that's clearly that's tangent alpha. Then when we cancel out cosine alpha in the second term in the numerator, we get sine beta over cosine beta, which is tangent beta. Here, both cosine alpha and cosine beta cancel out. What do we have left? It's going to be a1. Remember, when you cancel out factors, they don't disappear. They don't turn into zeros. They leave a factor of 1 behind. Okay, so I have 1, and finally, what do we have? Oh, well, we have a tangent alpha and the tangent beta. So minus tangent alpha, tangent beta. And that's our formula for the tangent of the sine, of the sum of alpha and beta. So this is our formula. This is what we started with. This is what we ended up with. And that's the formula that we're going to be using. So using the same logic or substituting beta with negative beta, we will come up with the formula of the tangent of the difference of the angles, which is symmetric, and wherever we had plus, we have minus now, and vice versa. So let's apply it. Straightforward. Our first example says find the exact value of tangent of pi over 6 plus pi over 4. So we're gonna apply our formula. Here we are, and the values of those tangents, tangent of pi over 6 and tangent pi over 4 are known values. So we will have no trouble filling them out. So that's what we get when we put the values in. I just wanted to point out that this one is actually a value of the tangent of pi over 4, this one and this one. Now this one, it comes from the formula, right? This is not a tangent value that comes from the formula. All right, so now we need to simplify it. I'm gonna turn 1 into 3 over 3, the first one and the second one. So I got this complex fraction. So I have one fraction divided by another fraction. So I'm gonna just rewrite it. I'm gonna turn the fraction into a division because that's what it represents, right? But as I combine the numerator and the denominator into one fraction. So here I'm going to have square root of 3 plus 3 over 3. And I'm going to divide it by here, 3 minus root of 3 over 3. And when we apply of division of fractions rule, so we turn division to multiplication and flip. This is what we get. Root of 3 plus 3 over 3 minus root of 3. But now if we want to rationalize our denominator, binomial denominator, we have to, remember, we have to multiply by its conjugate, the top and the bottom. So basically this expression is exactly the same as this. So now we're going to have root of 3 plus 3 squared. On the bottom, we have the first one squared, which is 9, minus the second squared, which is root of 3 squared is going to be 3. So in the end, we're going to have square root of 3 plus 3 squared over 6. So that's our final answer. And before we get to our next example, I would like you to try this one by yourself, tangent of 2 pi over 3 plus pi over 4. Please stop the video here and try this problem. And let's proceed to our next and the last example in this video. Example number 6, and says given alpha is 3/5. And also we know that alpha is in the first quadrant from 0 to pi over 2. And we also know that cosine beta is negative pi over 13. And our beta is in a third quadrant. So this alpha is in quadrant 1 and beta is in quadrant 3. Why is this important? Well, let's see what we need to do. We need to find sine of the sum of alpha plus beta, cosine of the sum. And we know that in order to find those, we need both the sine and cosine of alpha and the sine and cosine of beta. Also, we have to find the tangent of alpha plus beta and tangent of alpha minus beta. And for those, we need both tangent of alpha and tangent of beta. So we will, before we apply the formulas, we need to do some preliminary work. So let's do that. We need to find all the sine and cosine and tangent of alpha, and sine and cosine and tangent of beta. Well, the cosine is given, so I guess just sine and tangent. Okay, so let's do that. We know that sine alpha is 3/5. So we're gonna draw a triangle with alpha. The sine is 3/5. That means that the opposite side is 3 and hypotenuse is 5. So this side is going to be 25 minus 9, which is a square root of 16, which is 4. Okay, so that means that the cosine alpha, and remember alpha is in the first quadrant, so all the trig functions here are positive. So cosine alpha is 4/5, 4 divided by 5. And the tangent of alpha is sine divided by cosine, where sine is 3/5 divided by 4/5. So we're going to have 3/5 times 5/4. So the tangent alpha is 3/4. Okay, and so that's alpha. And we're also going to do the same thing for beta. So for beta, what we know about beta is that its cosine is -5/13. So in the triangle, if we take it out of context, take it out of the unit circle, we're going to use all positive values, but then we're going to put it in the context of quadrant 3 later. So the cosine is -5/13. Or we could just do it anyway. So this side is -5, and the hypotenuse is 13. The hypotenuse is always positive. Now, in the third quadrant, both sine and cosine is negative, right? So we're going to have a negative value here as well. So what is this? It's -√13 squared, which is 169, minus -5 squared, which is 25. So what does that equal to? That happens to be square root of 144, which is -12. So that means that, okay, the cosine beta is -5/13. Sine beta is going to be -12/13, and tangent beta is going to be our sine -12/13 divided by cosine, which is -5/13. So that gives us positive 12/5. So now all we have to do is apply our formulas, plug in the values that we just found, and that's it. So for A, sine of alpha plus beta, according to the formulas, is sine alpha cosine beta plus cosine alpha sine beta. So let's substitute our values. Sine alpha is 3/5. Cosine alpha is 4/5. Cosine alpha again is 4/5. And I'm sorry, this should be cosine beta. So cosine beta is given to us. It's negative 5/13. And then cosine alpha, which is 4/5, times the sine beta. So the sine beta is negative 12/13. So now when we multiply all of those values, we're going to get negative 15/65. Here, our denominator is also 65, and the numerator is going to be negative 48. So the result is negative 63 divided by 65. So that's our answer for to question A. Similarly, question B, cosine alpha plus beta. You can fast forward if you know how to do it, but I'm gonna write it out. So it's gonna basically it's the same thing. I'm just following the formula. And plugging in the values that we just found. So cosine alpha is 4/5, and then cosine beta is negative 5/13. And then the sine alpha is 3/5. And sine beta is negative 12/13. So again, when we multiply the fractions and subtract, what we're going to get, 16/65. All right. So basically, this is a sine and cosine of the same angle. If you want to check your work, you could square sine, square cosine, add them up, see if they add up to 1. And we're going to continue to question C. Question C is tangent of alpha plus beta. Again, just plugging in the formula. Let's write out the formula. And substituting the values. Tangent alpha was 3/4 plus tangent beta was 12/5. Oh, 3/4 multiplied by 12/5. Okay, so what do we have? We're gonna have, I'm gonna need more room. So what I did, I made sure that we have the same, found the LCD for all of these fractions. So obviously this is it's going to be 20. So I turned every term involved in this fraction with another fraction with denominator 20. And now I'm going to combine and divide. Okay, so here we're going to have 63 divided by 20 in the numerator and negative 16 over 20 in the denominator. Again, this is a complex fraction, which I'm going to rewrite as a regular fraction using the division symbol, and then turn the division into multiplication and simplify. So 20 and 20 cancels out, and we're going to have 63 over negative 16. Can that be simplified any further? I don't think so. I think 63 is actually a prime number. So yeah, no, we cannot. And 16 only has factors of 2, 4, and 8, which obviously 63 is not divisible by those values. Okay, so and the last, so that's the answer to question C. The last question that we have is question D. So let's answer question D. Question D is tangent of alpha minus beta. So again, it's just plugging in the values into the formula, writing out the formula first and then plugging in the values. So again, this is just copying the formula and then plugging in the values. We have tangent alpha is 3/4 and tangent beta is 12 over 5. So I'm going to apply the same strategy as in the previous question. We're going to find the LCD and combine. So I'm going to have 15 over 20 minus 48 over 20. 1 turns into 20 over 20. And then just multiplying. I'm going to get 36 over 20. Combining fractions in the numerator and the denominator. That's what we get. And now we're going to rewrite it using the division instead of the fraction bar, because we got a complex fraction again. Now turning this into multiplication and flipping the second fraction, we get negative 33 over 56. And can that be simplified? Again, I don't think so. The only factors of 33, 3 and 11, and they're not factors of 56. So this is it. We're done with this example.